What's going on, everyone? So now we are we're on to the next critical component calculation set. So basically we're going to work on the MOSFET now. We've already defined the transformer. We've already specified critical parameters for that one. So now we're going to do the MOSFET. So the first important parameter to consider when sourcing your MOSFET is the voltage drain to source peak. So basically, what this is just a measure of, it's pretty self-explanatory, the voltage between the drain and the source pins that it can handle before it becomes damaged. And maybe in a later video we'll get into why you actually, this voltage rating will be actually extremely high compared to like what you would expect. Like we're looking at like 600 volts, like you see down here ahead of me, it says 613 volts, probably like, why is it experiencing voltages that high? And maybe I'll get into a later video as to why that is. But the only important thing, the bare minimum that you need to know is if you look in the data sheet, it gives you an equation like this. And I think I have use this one because if you look around on the internet, there's actually like every data sheet will have like a slightly different way to calculate this, which is, I don't know, a bit confusing sometimes. But we'll probably learn more about this whole process whenever we go through and have to calculate, do this step multiple times whenever we start designing more stuff. But anyways, I'll just get into the equation, right? So VDSPK, or voltage drain to source peak, is going to be equal to Vn max times the square root of 2 plus VOCV plus VF plus VOCBC plus N sub PS plus VLK. So just to give you an idea of what all those parameters mean, I think we've gone over several of them or most of them, but the VOCV one is the regulated output voltage, so that's what we set. VF is the forward voltage of the output diode. VOCBC is the target cable compensation voltage, so that's like 16 millivolts. Remember, we set it up there. NPS is our primary secondary winding ratio. We set that already. We know it is. It's 15. VLK is the leakage inductance. So in the data sheet it says estimated leakage inductance energy reset voltage. So this is equal to 150 volts, and I'm not 100% sure where I got that from. I think I calculated it. I don't know if it gives it to us in the data sheet. Maybe search for like VLK. So it appears, what I think I did was I calculated it through some other method. I think I just looked around online and was able to come up with a number. Hopefully I can figure that out and explain that better. But this is, oh, okay, I remember what I did. So what you do to calculate the V leakage is you'd take the output voltage times the NPS value and then multiply that by 2. So we have 5 times 15 times 2. So I'll just get out a calculator real quick. We do 5 times 15 times 2. 150, right? Now to explain why we're doing that takes a whole other story here, but just know that's how I got that number. This is also known as the reflected output voltage in some cases, in case you actually come across that term, and maybe if you're doing another project or something. So anyways, so when we plug in all those numbers to the equation, we come out with 613 volts. So again, basically the trend here is that we need to pick a MOSFET with a VDSPK rating that is higher than 613 volts. You don't want it to be right at that, because if any of the conditions are a little bit off, or if your calculations are a little bit off, then it could just spell disaster for your project. So you want your project to be able to handle a whole lot of situations, and it's pretty simple to find parts that can meet this specification. The next important component parameter, in my opinion, is the current continuous drain rating. So basically this is just like, it's pretty self-explanatory, and continuous current that is going to be flowing through this the MOSFET, right? So in this case, I just said it needs to be higher than our peak current. Now, I think from what I remember sourcing the MOSFET, I didn't have any trouble finding something that was able to meet this value easily. And this is the peak current. So this is just, again, this is like a safety precaution to make sure that our MOSFET can handle all the conditions, right? Say worst case scenario is we're seeing something like this continuously, like just know like that. Just remember that's kind of what that's a good like note for engineering, is that we're just trying to take the worst case scenario and we're just trying to prepare for it is a good way to think about it. So yeah, that's pretty much all you need to know for calculating your MOSFET component parameters. So like when you're shopping, like I said, look for something that has a voltage drain to source rating that we need, and then can also handle the current rating that we have specified right here. So that wraps it up for the MOSFET portion of this series.